Hello, I thought I'd make a final wrap-up video to go over some tidbits that I may have missed and some other useful tools. So it's going to be just a compilation of random techniques. So the first thing I'm going to show is the concept of relative references. And I think a good way to demonstrate this is to conform an object so it sits on the floor regardless of what transformations are made to it. So if I hold Control and put down this tube, let's dive inside and maybe give it some end caps. Right now it is aligned to the center of world axis, and what we want to do is have it so that it's sitting on the floor. So let's put down a transform SOP and flag it. And in this case we want to conform our Y translation to another parameter that we want to tweak. So I'm going to go with uniform scale, and so in this case we want to use this parameter as a relative reference. So I'm going to right click on it and go to copy parameter, and we want to paste this on our Y translation, so I'm going to go paste relative references. So whatever the uniform scale is going to transfer right over to our Y axis. But since we want it on the floor, I'm going to divide this by 2. Now regardless of my scaling, the tube's going to sit on the floor. I did skip the snapping tools over here, but it's very straightforward. If I want to snap to our grid, I'll just click this, and if I move our tube, it's going to be snapping to the absolute values of our grid. So here I can move it exactly 1 unit in the Z-axis. The rest of the snapping options are for primitives, points, and multi-snapping. So when I went over the attribute transfer node, I simply transferred the color from a sphere to a grid. But what if we want to drive any other attributes with the transfer? I'm going to be using a grid and a sphere inside of our SOP. Let's give both of these a color. We'll have the grid be black, and a simple way of doing this is right-clicking on the swatch and clicking on Set to Black. The sphere is going to be red. So let's make our red value 1 and the rest 0. So if we visualize the sphere, it's red and the grid is black. Let's put down our attribute transfer and transfer our attributes from our sphere to our grid. Here I'm gonna put down my distance threshold, blend width, and let's give the grid more resolution. I'm gonna make the blend width very wide and the distance threshold quite small, so we have a spread all along our grid. So let's try simply displacing these individual squares in the Y direction, and let's drive this by the color. So the first thing we have to do is transfer our color attribute from points to primitives. So if we open our spreadsheet, we're going to see that our attributes are on our points. So our red color value is going from 0 all the way to almost 1. What I'm going to do is promote the point attribute to the primitives. So basically we just want to put the red color value inside our primitives, because right now we're applying our color to the points. This is done by an attribute promote SOP. And here we can choose our color and promote it from our points to our primitives. Now if I open up the spreadsheet, we have our color on the primitives over here. So let's flag that. So now I want to split all of our primitives apart from each other. Right now they're connected, but I want them to be separated. This can be done with a facet SOP. By simply clicking unique points. Now with a primitive SOP, we're able to transform our primitives individually. So let's click on Do Transformation and scale them all down uniformly. And there we go. We're getting some split polygons. So now I want to drive the Y scale with our red color value. How do we do this? In this case, we can make a vex expression in our Y channel here. So I'm going to type A for attribute, C, D for color diffuse, and R for our red channel. We can also use X, it'll do exactly the same thing. So I'm going to click away to execute, and here we have our red color driving our Y translation. So now, if I move this sphere around, I'll use our constraint handle. It's going to be transferring it accordingly. So the color attribute is being transferred not from the periphery of the sphere, but the point inside of it. Because this sphere is a primitive, it only has one point. We can see this by middle mouse clicking our node, and here we have 1 point. We can also do this by clicking on this node info button. Notice as soon as I switch this to polygons, we're going to have a much wider radius of influence, and in this case that's not what I want. Next I want to talk about different ways to scatter points onto geometry or volumes. Let's put down a rubber toy. And I want to scatter some points randomly on the surface of our rubber toy. This is simply done with a scatter sop. Let's visualize it, and we have random points on the surface. This is the total count of our points. So we can populate it or reduce it accordingly. So what if we want to scatter points inside the volume of our geometry? This can be done with a points from volume sop. Let's flag it and see what happens. So whenever a node comes with a visualization guide, such as this blue wireframe on a rubber toy, sometimes there's an option to get rid of this visualization, but in this case I don't see one. So when I run into this problem, I put down a null and visualize that. So here we have a very uniform scattering of points inside our rubber toy. We can make this more random by increasing the jitter scale over here. And this point separation is sort of the same thing as our total count in our scatter. So the smaller this value is, the more points we have scattered. The scatter sop can also put points inside of objects, but the object needs to be converted to a volume first. So there are various ways of turning geometry into a volume, but one simple way is to use the ISO offset sop. So if I put it between our geo and scatter, now our scatter is going to work inside. If I flag our ISO offset, we can see a visual representation of our volume. We can increase its resolution by cranking this sampling subdivision slider. This is a good opportunity to show an older way of fracturing an object before Houdini came out with its RBD fracture node in version 17. So if we want to break down the rubber toy into chunks for a fracture sim, first we need to scatter points inside of it, and we probably need way less than this. And these points are going to be the centers of our chunks. So now if I lay down a Voronoi fracture sop, it needs geometry to fracture and points for the cells. So we are fracturing our rubber toy, and the points are going to be the points that we just scattered. Let's flag this, and here we can see that our geo is fractured into pieces. We can use exploded view to visualize it better. One important aspect of VOPs that I missed is the concept of binding, which is basically bringing in and taking out attributes other than the ones that we see that are available in our input. So I'm going to use the same geometry. Let's put down an attribute VOP. As I went over in my attributes lesson, here in the input node we have all of these implicit attributes that are already sort of on our geometry, or ones that are often used for operations within VOPs. But what if we want to bring in another attribute that we don't have listed here, say a custom attribute or something we can generate from another SOP? This can be brought in as a bind SOP, manipulated, and then brought out again with a bind export SOP, so that the attribute will be applied to our geometry. First, let's create our custom attribute. I'm going to put down a measure SOP, and we're going to create a curvature attribute for our rubber toy. Let's plug it in, and measure the curvature. I'm going to flag it. And right now it's measuring the curvature on the primitives. So anything that's blue would be concave and everything that's red is convex. Since in this case our VOP is working on the points, I want to transfer our curvature attribute from the primitives to the points. So I'm going to put down a geometry spreadsheet by splitting our pane and choosing geometry spreadsheet. Now when I go to our primitive attributes, we have a curvature value on each of our primitives. I want to copy this value from our primitives to our points, so I'm going to lay down an attribute promote SOP. If I change our original class to primitives and click on this drop-down menu, we're going to have all the primitive attributes that are available to us. So if I choose curvature and promote it from primitives to points, here in our points menu we have a curvature value. The curvature is deleted from our primitives, and that's because this delete original checkbox is selected by default. In this case we don't need it, so I'm going to keep it there. So let's plug this into our VOP. And here we have access to the curvature if we put down a bind. So again, a bind brings in any attributes that aren't listed here. So if I go inside here and type in curvature, we now have control over the curvature and we can manipulate it with other VOPs. Let's put down a ramp. So this is a ramp parameter. So it's basically a gradient. Right now it's scalar. Let's change it from RGB color ramp to spline, which basically changes it from a vector to a float. I'm going to plug my curvature into the input and plug the ramp output into CD just to visualize it for now. Now when I flag this, we should have curvature data, but I think our original texture is blocking it. So if I go back into our original rubber toy and unclick Add Shader, we're going to get rid of that. In our attribute VOP, we have control over the ramp. So basically everything's at 0 right now, so we're getting black values everywhere. So as soon as I bring up this first point, we're going to be getting some data. But we're still not seeing our curvature, so let's see what's going on inside. I'm going to visualize the curvature directly, so I'll put it into our CD. And here we have some values. And these color values should correspond with our curvature attribute. So as we can see, we're going from this value to this one. And what I want to do is fit these values between 0 and 1. So let's put down a fit range. And here we can remap our values. So just to visualize, I'm going to pipe this fit into our color and crank up our maximum value until we get white. So here we have a good representation of our curvature. So I'm going to put this fit into our ramp and then put the ramp into color to visualize. Let's see what we get now. So now we have control over our values with our ramp. But what if I want to export this newly created attribute that we have control over down our node network? So back in my VOP, I can do this by using a bind export VOP. Let's plug our ramp into here and export this with any name you want. In this case, I'm going to call it fitted curvature. So here we still have our original curvature and our fitted curvature, and we can use either one of these values to drive our other manipulations. Now I'm going to extrude these primitives based on the curvature. So what we need is this fitted curvature to go onto our primitives, which we don't have. So again, I'm going to go up and create an attribute promote and take the point attribute of fitted curvature and promote it to primitives. This is because our polyextrude SOP needs primitive attributes for its variable manipulation. So now if I pipe this in and flag it, we're going to have extrusion uniformly right here. But if I go to local control we can set a custom attribute to drive our distance scale. So this is going to be our original value, and the distance over here is going to be a multiplier for it. So I'm going to type in fitted curvature. And the one other thing we have to do is change this to individual elements. And by the way, sometimes guides for SOPs can be turned off by simply getting out of the handle gizmo here. So if this is on, which it was when I laid this down, we're going to have these green visualizers, but if I navigate away from it, they're going to disappear. So here we can see the color of our fitted curvature as well as the extrusion. So all the black polygons are not being extruded and the white ones are being extruded. So one thing that I missed about groups is that we can use another geometry to encapsulate our points, primitives, or vertices to include them in the group. So let's put down a group and plug in our rubber toy. In our spreadsheet, we have a primitive group. I'm going to change this to points. And in here we have our group. And as we can see, all of our points are inside of the group. Because again, 1 will include them and 0 will omit them. I want to use another geometry to include some points in our group. There's two different ways of doing this. The SOP itself provides us with this option. If we click on Keep in Bounding Regions, we can choose a bounding box or a sphere to include certain points in our group and exclude others. So now everything that's inside of the sphere has a value of 1 and everything outside of it has a value of 0. What if we want to use a custom geometry to do the same thing? Here we can simply change this to bounding object, and let's use a torus. So I'll plug this into this input, which is labeled bounding object, and now everything inside our torus has a value of 1 and everything outside has 0. Let's visualize this. I'll put down a color SOP. Let's color everything we want to see in the group green. And let's pick our group from this drop down. I'm going to take my torus, and if I move it around, we can see that our group values are changing. As an aside, I want to talk about changing the default parameters of any node. So say I think that this torus has too big of a radius. I'm going to center this back to 0 and put our second radius value down so it becomes thinner. Let's round this down to 25 and say if I want this value to be in our torus by default, I'm going to click on this gear and go down to Save as Permanent Defaults. I want to touch on a feature that lets us switch between selection modes. I'm going to flag my rubber toy, and when I click on my selection mode and this icon over here that's labeled Select Groups or Connect to Geometry, we have this menu that lets us select certain aspects of our geometry based on different values. So here we have groups, but now that I have my mesh flagged, we're not going to see anything but 1 over here because everything is in one group. Let's create another group to see this in action. Gonna lay down one more group node, and let's use a sphere as a bounding object. And let's move it so that it goes over the head. Gonna increase the size a little bit. So now we have two groups. Since this selection is for primitives, our groups have to be primitive groups. Since our first group is on points, I'm going to switch this to primitives. And it's unable to calculate it for us because we have a limitation with our bounding object. It can only be in points or vertices only. So let's use a sphere for this one as well. This time I'll put it on the tail. So I'll move it up a bit and back. So now if I select this node, we have both of these groups, and we can make our selection based on the groups. So if I select this and press delete, we're gonna get a blast node which deletes the primitives which are inside of our group. Let's go back to our original geo and back into the selection menu. We can make use of connectivity to select our various pieces. So because this geometry isn't fused into one complete mesh, these parts can be selected individually as they're not actually connected. We can also select based on paths, which we can create with groups when exporting geometry, or a name attribute. We can also select by attributes. Back in my DOPS lesson, I didn't actually go into a Pyro setup. I simply clicked on the shelf tool, but didn't go into the networks that it created. Let's put down a new test geometry we haven't seen, which is the squab. Let's make it emit some smoke. So again, if I go into my Pyro effects shelf, and let's choose the billowy smoke, it navigates us directly into the DOP, which is put into our object context. But how does it prep our geometry so that it's optimized to go into our DOP network? Let's dive inside here and see the nodes it created. The first is a Pyro source SOP, which optimizes our mesh for a Pyro sim. It creates density and temperature attributes and gives it a resolution. Next we have attribute noise, which applies noise to our points. And finally we have rasterize, which turns it into volume. This voxel size uses the same technique we explored with putting the tube on the floor by copying a relative reference. So this voxel size is dependent on this value here. So this is using a channel function to fetch the particle separation inside our create density, our Pyro source SOP. So this one over here. It's then multiplying it with another channel, which is the particle scale, also in here, and then dividing it by 4. Let's go up, dive into our DOP network, and run our sim. So we have this rising smoke, and I did go over our resolution in the DOPS lesson in here. So let's change this to max axis and make it 200. And here we have a more detailed smoke sim coming from our squab. So that's all I had planned for today, and this concludes the Houdini Basics series. Thanks so much for watching. I hope you learned some fundamental aspects of the Houdini workflow, and stay tuned for more videos. Bye-bye.